So start with the first question. So here we've been given three vectors and the magnitude of a plus 2b plus 3c has been given. I guess what we can do here is sort of take the dot product of a plus 2b plus 3c with itself. So that will be equal to 21. So this will be, I'm just using small a for the magnitude of a. 9c square plus, and then we can sub in the magnitudes of b and c in terms of a that has been given in the question. So you get a square plus 16. So all the dot products will get a cos theta term of half. So I guess we'll have to divide by half everywhere. So we have the magnitude of b, that's 2a, and then you also have a half, so that gets cancelled out. You get 2a square here. Then b dot c, you have 3 times 2 and a half again. So you get 12 a square. And you get 18 a square. And then only you have 9 by 2a square. This entire, this will be a square equals 21. So now if you solve further, I erase that off. Then it's just some calculation that I have to do here. So not wrong, we get 147, and this is 21 times 7 equals 1 by root 7. So the answer here, c is 3 times of a. If you multiply that with root 7, you get 3. Now for the equation of a plane is, you've been given the vector it's perpendicular to. So that will determine the direction of the plane. And then you've also been given a point which it passes through. So that decides the plane uniquely. So take any point on the plane. Let's call it the vector r, the position of the point. So if you subtract, let's say b, the point b from that, you get a vector that's parallel to the plane. And since the plane is perpendicular to vector a, this must be 0. So from this, you get the equation of the plane. It will be 2 times x minus 1 plus 3 times y minus 5 plus 6 times z minus 3 equal to 0. Then you can write it in the normal form. So if you're familiar with the equation, the plane in the normal form, basically what you do is you just normalize the constant term so that it becomes 1. So you get 2x plus 3y plus 6z equals 2 plus 15, 17 plus 18, 35. And then you have 2 by 35. So now the distance is just the root of the sum of squares of these coefficients. So you get, so we want to find the square of the distance. That will be 2 square plus 3 square plus 6 square, 36 plus 13, 49 by 35, 7, 5, say that 1.4. Okay, so here is again a pretty basic question on vectors. You just need to know a bit about how vectors add up. There are quite a few ways how you can approach such questions. I think if you're not really sure about what to do, I think one good idea might always be to take a dot product. So here you have 3 unit vectors, and if you take the dot product of the equation with A, B, and C, you'll get equations which you can solve and then find out the dot product between A and B. So another thing that I notice here is that the sum of A and C is root 3B. So what you can, or actually a better way might be to do this instead. Yeah, I'm sorry. A minus root 3B equals minus C. Now you take the dot product on both sides. So the magnitude of this is equal to the magnitude of this. You get a square minus plus 3b square minus 2 root 3 a dot b equals c square. So I just did this so that I can just get an expression that contains a dot b. And since I know that their unit vectors, their magnitudes are going to be 1, and that means I get 2 root 3 a dot b equals 3. So a dot b equals root 3 by 2. And that's the cosine of I base x. So don't be intimidated if I'm solving these questions quickly. I actually had a look at the paper of the first 10 questions around. So that is why I kind of already I had some time to think them through already. So rather than trying to solve them quickly, I'll just try to explain stuff that might be useful in solving such questions. So now in this question, the very naive way of doing this might be to just sub in x square plus 1 and then 2x square plus 2x plus 3 into the equation and then trying to solve it. But that is going to make it really hard to solve. So, and in general, if you see such a question and you think that your approach might be very lengthy, then it's very likely that your approach is wrong. So a better way to do this would be to first factor f of x so that you can notice how the function behaves. So in this case, if you factor out the x, you get x square plus 3x plus 2. And by the way, I just skipped the a because the a wouldn't really have any effect on its inequality. You're just adding an a on both sides. That'll get cancelled out anyway. So let's just ignore the a. Let's just call it 0. And then this factors further into x plus 2 times x plus 1. So now if you plot the graph of the function, it's going to appear something like this. Passes through -2, goes to -1, goes all the way down. And what I also want you to notice is that x square plus 1 is obviously greater than 0. And also 2x square plus 2x plus 3 is greater than 0, because if you look at the determinant of this quadratic, it will turn out to be less than 0. It's 4 minus 4 times x. So that means both these terms inside f of x, they're greater than 0. So we're only concerned with this part of the graph where we know that it's monotonically decreasing, which means the lesser the input, the greater it's going to be. So basically all we want to solve for is x square plus 1 less than 2x square plus 2x plus 3. So if you subtract x square plus 1 from both sides, you get x square plus 2x plus 2 greater than 0. That's x plus 1 whole square plus 1 greater than 0. So this is always true. So it will be true for all real x. You know, this kind of similar question, I guess you have to figure out the domain of the function. I think this is a typical JEE question. No, I don't think it's a big deal for any of you, but solve it anyway. So the term inside the logarithm, it has to be, it is the negative power of a fraction. So it will be greater than 1. So this term should be greater than 1. And this is greater than 2 power 1. Right? So this entire thing here is greater than 2. Now since mod x minus 1 is greater than 0, I can just multiply it by it on both sides. And I get this inequality. I guess one thing you can do is just take cases x greater than 1, x less than 1, and then solve. So what I notice here is that I can just plot the graphs as well. I think a good approach always when you see such terms is to look at the graphs of the functions so that you get an idea of how they behave. So this is x squared plus 1. Let's say this is 1, 2, it's 1. And this is 1, I guess 2 times mod x minus 1 might look like this. So let's call this 1. So is 1. So this how 2 times mod x minus 1 looks like. And the slope of this is always 2, whereas x squared plus 1, it only increases from 2. So on the right side, it's not going to intersect this function at all. We just need to look at these 2 points of intersection, and then x squared plus 1 will be greater than this function everywhere else, right? So we want to find this region. So basically you just have to solve this inequality and then take the exclude this part from the real number line and you'll get the range of x. So here I don't see any options really, so I'll just skip this, but it's just a matter of solving the equality after that. Yeah, I think this is straightforward arithmetic again. We'll just do that always. So and this is just some basic properties of logarithms that you should look up if you're not familiar with. So I think we need to get some sort of an inequality here. So one thing that I noticed is that since a and b are both greater than 1, these log terms are always going to be positive if let's say the base is e or something. So this entire thing, I can say it will be greater than, I can find a lower bound for this using the AMGM inequality. So this entire thing, I'll just put a bracket here to do some by 2 will be greater than or equal to, if you take the product of this, it's just going to be 1. So this entire thing is for sure greater than greater than or equal to 2, right? So that means this term is always going to be less than or equal to 0. So 1 is going to be the wrong answer. So this next question, we have f of x equals x squared times g of x. And then you've also been given another property of the function. So generally, if such a property was given, f of x plus y equals f of x plus f of y, I assume the function to be, let's say, the identity function or a logarithmic kind of function. But then here it says that the function is supposed to be continuous at 0 also, I gather from the options, because you have g of 0 and stuff in the options. So I'm not sure. I guess I can't do that over here. Let's just go ahead and differentiate this and see what we get. So if we differentiate f of x, this is going to give us 2x g of x plus x squared times g prime of x. Okay. So now I'll have to leverage some of this property of the function that f of x plus y equals f of x plus f of y. So I'm not quite sure how I proceed with this, but let's see. So right now I can't really think of a way of proceeding ahead. So what I'm going to do is just mark this question for review and then come back to it. I think this is just a question of like, I mean, the h of x is basically this. It's just g of x, so it'll be minus 2. So if we just plot h of x, I think that's going to be enough. So h of x, it becomes 0 at x equals 0 and x equals 4. So this is 0, 4, this is 2. And at x equal to 2, it takes on the value 2. So the function's graph is going to look something like this. So the reason I'm able to do this is I know that h of x slope can be either -1 or 1, and the only points where it is non-differentiable is the critical points. So everywhere else I know that it's going to be of this form. So if I just figure out the critical points, I can join them and then figure out what the graph will look like. So now that I know the graph, I'll just have to add up their slopes. So at -1 you get -1. At 1 you get 1. And then at 3 it's -1 again. And then at 5 it's 1. So you end up getting 0. Okay. So what the question usually says is you have two angles satisfying this equation. Let's say 3 alpha cos A plus 2 beta sin A equals gamma. And also we have 3 alpha cos B plus 2 beta sin B such that A plus B equals pi by 3. Okay. So let me just have a think over this. You just want the range of values 2 gamma. Yeah, I can't really think of any promising way to proceed off the top of my head. So I'm going to let go of this for now and also mark this for review. I think this is just asking for the period of the function. So if the period of the function is 10 and pi, so that's the least number after which it's going to repeat, obviously. And so let's look at the individual periods. Sin x by 3 is basically the graph of sin x, but it's been stretched out by 3 units. So that means the time period is going to increase 3 folds. So that will be 3 times 3 times 2 pi. And then for cos 3x by 10, it's been like shrunk, let's say by a factor of 3 times. So the time period is going to increase by 10 thirds. It will be 2. So now we want the entire function to repeat, right? So we want the time period of this and the time period of this to kind of, I mean, we want the value of this and the value of this to kind of start repeating again. So we'll have to look at the, and say kind of like the LCM of their time periods. So if I multiply by this by some natural number and also this by some natural number, I have to look at what the smallest natural numbers are so that this can happen. So obviously k has to be a multiple of 3 so that we can get rid of this 3 at the bottom. And then you need to, m has to be a multiple of 10 so that it can divide this. So what I see is k equals, I mean, say if we take m equal to 10, so the least number that divides 10, then k will be equal to 9 so that this entire thing can become 30. So basically the period of this, it will be 30 times 2 pi, right? So if you equate that, that will be the period of the entire function, sine x by 3 and cos x by 3. I'm sorry about this. Yeah, that will be the entire period of this function. So that means you want n to be 6 because you have a 2 here and that's 30. Okay, we have another question without options, but then we'll solve it anyway. This is a straightforward geometric series question. So you can write f of x as 1 plus 1 by 1 minus sin x. And sin x is ranging from -1 to 1. And obviously the greater sin x is, the lesser this entire thing is going to be. So the greater this term is going to be. So it's a monotonic function. So its extreme values are going to be 3 by 2. You put sin x equals -1 and then infinity. And that's going to be the range. But then, yeah, we don't have a option here. So let's just move ahead. Okay. I think this question, I don't know. I mean, I think this is a pretty straightforward question because it might look intimidating, but then it's a really straightforward question. They're just asking you how many distinct terms you can get, which means how many distinct powers of x you can get. So that will just be all the possible powers of x power 4 times n, where n goes from 1 to 100. And similarly 1 by x power 4n, where n goes from 1 to 100. And then you'll also have a constant term. So you'll have 201 terms in total. And then any term that is kind of formed by taking a mix of the powers of both. So x power 4 times a p and then 1 by x power 4 times q, that will be of either this form or this form. So we don't have to count that again. I think the answer is just 201. So this question, it deals with divisibility. So often questions that deal with divisibility, you can solve them using binomial theorem. So you do a binomial expansion that's sort of suitable. So you do a binomial expansion that involves the number you're dividing with, so that you can figure out what the remainder will be. Another useful tool that you can learn, I don't think you can use that in this question, but I think modular arithmetic is something you can learn in general that will help you solve such questions pretty easily. So here, yeah, I mean 9 and 7, they're 1 above 8 and 1 less than 8. So I think if you notice that, you can just do this binomial expansion. So I think it might seem, I mean, if you have never seen such a question before, it might seem like I'm pulling these tricks out of thin air. But then it's just a matter of pattern recognition, really. Like I'm able to do this because I've seen such questions before. So the more questions you solve, the more patterns you know, and then more you'll be able to solve easily. So if I expand this out here, this will be 1 plus 7 times 2 cube plus 7c2, that's 21 times 2 power 6. And this will be minus 9 times 2 cube plus 36 times 2 power 6 and so on. So now this 1 gets cancelled off. And the first term, it becomes 16 times 2 cube. So that is 2 power 7. But then in the second term, it remains, it's only divisible by 2 power 6. So I think that kind of puts a cap to the max power that it can be divided by. So it will be divisible by 2 power 6. Okay. So I think this question, it will become pretty easy to solve if you notice that even if you include higher powers in the expansion, so 1 plus so on up to x power 8, whatever is given in the expression, and then some higher powers, that's not going to affect the answer. Because the degree 8 term you'll only get from these terms out here. So if you notice that, you can write this in terms of the Taylor series of e power x. You'll have to notice that as well. So often when you see series that involve factorials in them, somehow the Taylor series of e power x is going to pop up. So if you haven't seen such questions before, I think this is something you should tuck off at the back of your head. So you can you have only the even terms of the Taylor series of e power x here. So that means you can get it by adding up e power x and e power minus x and then dividing by 2. Then it has been squared. Say that 1 by 4 times e power 2x. The coefficient of x bar in both of these is going to be the same. You can multiply it with 2. It will be 2 power 8 by 8 factorial. Now it's just a matter of calculation. So this will be, I'll just break this up according to what terms you get in the factorial of it. So if you do this, this gets cancelled out. You get a 3 here. So the denominator must be divisible by 5 and 105 is too small and it's odd, so it has to be 1 by 315. Okay, so we're given a curve that has been parameterized by this parameter t. So when you do this, and where t is basically running over all real numbers, so all the collection of these points, it forms a curve. And we want to find the number of straight lines passing through the point 2, 2, which are tangent to the curve. Okay. So if I want to figure out a general tangent to this curve, I guess one thing that you can do is find the curve in terms of x and y. So I think it's going to be a parabola which has axis and directrix along x minus y and x plus y. Get e square plus 2. Or I think an even better way might be to just find the derivative in terms of t. So dy by dx is just dy by dt by dx by dt. So you'll get 2t minus 1 by 2t plus 1. So our tangent will be of this form. This will be minus. And has to this line has to pass through the point 2, 2. So let's just sub that into the line. If it passes through 2, then just set this equal to 2 and set this equal to 2. So the 2 gets cancelled out. You get e minus t square 1 by plus t square. And then I guess you'll have to solve for t and figure out like the number of values of t you get is basically the number of tangents possible. So each t will represent a single point. T square plus t. This is just going to be a simple quadratic equation. This term gets cancelled out, and also a t gets cancelled out. So you can represent this as e minus 1. In fact, it looks like there is going to be a linear equation, right? So if there's a point at all, it's going to be a single point. You have t minus 2t minus 1 equals 2t minus t minus 1. So that means t equals 0. That's the only point. Okay, yeah. So t equals 0 is the only point. And in fact, if you had noticed in the question earlier, when you sub in t equals 0, you get the point 2, 2 itself lies on the parabola. So sort of you have only one tangent passing through a given point in a parabola. So the answer is going to be 1 here. let's move ahead. The range of A is such that the line, okay, this again a question on tangent and normal and stuff. So now we have to figure out what the equation of a normal looks like. So if xy equals 1, so and parameterize it by e and by t. And then it's the slope of the normal will be minus dx by dt by dy by dt. That'll be 1 t square. So the slope of the normal is just t square. So get y minus 1 by t square times x minus t. And now you just have to compare this equation with the original one. Here you have y equals t square x minus t cube plus 1 by t. In this equation you have y equals 1 by 5. This log term here minus 1 by 5. So that means this entire log term here, if it's t square, then this will be this thing out here will be equal to t cube plus 1 by t. I think one thing, if you will notice here, the domain of this function in here, so this in here is 1 plus 5a minus a square. So this, if you just plot 1 plus 5a minus a square, let me plot it out here. So it's going to look something of this sort, look like, really sorry for the bad drawing, but okay, yeah. So it's going to look like this, which means you can definitely neglect minus infinity and infinity, because the term inside a logarithm, it cannot be negative. So if there's an answer, then it's either 0, 5 or none of these. So we just have to check if 0, 5 works. Right. So the actual domain would be from here, from whatever the root of this, whatever the roots are. And I think at 0 and 5, the value of this function is 1. So we are looking at this part. So let's see if that is indeed true, or if we can find something outside it, or even if that does not work. Okay. So we have t square. I mean, I think we might have to find a better way here, because this is going to take a lot of time if you do it the brute force way. So you'll have to find out a trick, sort of. Maybe we can get back to this later, because I'm not able to think of an easy way to get to the answer. Let's look at this question. Okay, I think now this is a pretty straightforward question. So the slope of the tangent anywhere, it's just dy by dx. So that will be equal to tan theta. So, and if you look at the angle with y-axis, so if this is, yeah, so if this is theta, then obviously this is going to be pi by 2 minus theta, and the slope is tan of pi by 2 minus theta, which is cot theta. So all you have to do is figure out the slope of the function. So if you just differentiate the function, you get 2x plus 4, and then put in 5 by 2 in place of x, you get 9. That will be the answer. So this matrix, if you just multiply it with itself, you can see you're always doing this sort of product. So you'll get a 3 at every part of the matrix. So you can say a square will be 3a. So a cube will be 3 times a square, which is 9a. Okay, so here, I guess, I mean, this relation is symmetric for sure. If B is the inverse of A, then A is the inverse of B. And it's not always reflexive. It's also not always transitive. I mean, A comma B, B comma A is present, then A comma is not present. So I think you can say it's neither reflexive nor transitive. Okay, so you asked us to, we have the equation of this line, and basically what the question is trying to say is that you just need two parameters rather than three to decide the equation of a line. So you could rewrite this to be a by cx plus b by cy plus 1 equals 0. So rather than figuring out a, b, and c, you don't even have enough information to figure that out. You just have to figure out a by c and b by c from the equations given. So if a plus 2b plus 3c is 0, and also 3a plus 2b plus c equals 0. So that kind of tells you that a and c should be equal. So if you look at these equations, and if a and c are equal, that means b would be equal to minus 2c. And that satisfies both equations. So you have x minus 2y plus 1 equals 0. Yeah, have an option that matches with that. This is another simple question. I think you basically have lines of this form. So x plus y equals n would look like this, and x plus y equals minus n would look like this, and x minus y equals x plus n will look like this, and y equals x minus n will look like this. So this is in fact a square. This is n here, and so the area will be half times the product of the diagonals, since the diagonals are perpendicular. So if this equals 2, then n square equals 1. How much time have I taken so far? Okay, around 25 minutes. So I think in a typical JEE main paper, around 1 hour 15 minutes should be the ideal time you give for math. But then since I'm a bit rusty, and also it's a bit difficult to use the whiteboard, I'll take a bit more. So you have two adjacent sides of a rhombus. Okay, so one side of the rhombus lies on the x-axis and the other on this line. Y equals 3 by 4x. If the length of the diagonal passing through the origin, so you have this diagonal, and this is given to be 4 root 5, and you've been asked for the length of this diagonal. So if you think of this in terms of vectors, you've been given the magnitude of this. If you call this A, you call this B, and you want to find out the magnitude of this. Okay, so in order to be able to do this, we'll have to first figure out what the magnitude of A and B has to be. So let's using the magnitude of the sum of two vectors, you will get this sort of thing. 2a dot b equals 4 root 5 whole squared. So that will be 16 5 80. And so you also know that tan theta, the angle between them, that is equal to 3 by 4 because this line is y equals 3x by 4. So cos theta will be 4 by 5. So get a square plus by 5 equal to 80. And what we want to figure out is this, right? We want to figure out a minus b whole square. So okay, one way of doing that might be, let me just check. So you want to figure out this. Minus 8 by 5 maybe. Okay, yeah, so you also know that it's a rhombus. I forgot that a little bit. So that means b square is basically just a square. So this equation becomes 2a square plus 8 by 5a square equals 80. Yeah, so sorry, there was a bit of disturbance. Okay, yeah, so you just basically have to figure out the value of a from this. You have a square equals this 200 by 9. So from that you can figure out 2a square minus n by 5a square, and that will be 2 by 5 times 9. So you get 80 by 9. Now that's close to 9, which means our answer should be a little bit less than. Okay, so none of the options seems to match. Let's just do the calculation again. So you have a square s plus 2 times 4 by 5. So that's a square equals 80. That means square plus so 9 by 5 a square 40. And now you want to figure out 2a square minus 8 by 5 a square. So 2 by 2 into 5 by 9. So 80 by 9, well, that's supposed to be like slightly less than 81 by 9, right? That's supposed to be slightly less than 9. So, well, I'm not really sure. I'm not getting the answer. I'll just mark this for review for now. Yes, you've been given the equation of pair of straight lines. And along with that, you have a third line. And the three of these, they form an isosceles triangle. That is right angled at the origin. So you have pair of straight lines passing through the origin, and they have to be right angled at the origin. And then this line, 2x plus 3y equals 8, it cuts them both, let's say, this way. So such that these two distances are equal. And we'll have to figure out the value of a plus h. So first, I think let's just try to look at the relation between the coefficients and the difference between the slopes of the line, right? So if you were to have y minus m1x and y minus m2x, so we'll rewrite this as divide this entire thing by a. So we clearly want m1 m2 equal to -1, which is already the case. So we don't have to worry about the right angle part because the equation of the line itself guarantees that there'll be a right angle. So all we have to do now is make sure that you have an isosceles triangle. So if you try solving these two equations simultaneously, this and then this, you'll get 2 points which should both be equidistant from the origin. So since those 2 points are equidistant from the origin, you can represent them as or cos alpha or sin alpha. It's 2 points on a circle with origin as the center. Now this will have to satisfy both these equations. In general, if r cos theta, let's say, satisfies these two equations, you get something of this sort. 2 cos theta is 3 sin theta equal to 8. And then you have 2r cos theta. And you have r cos square theta, r sin square theta, so that will be r square cos 2 theta plus h by a r square sin 2 theta equal to 0. Now, all that's left to figure out is what r is. So from this, we know what the value of tan 2 theta would be. So if we just write that down here, tan 2 theta, that will be minus a by h. And then now that we've figured out the value of tan 2 theta, we need to use that in this equation. Then what we finally want to figure out is a plus h. Right. So let me just, what we want to figure out is a plus h. And how do we do that? So I'll need a moment to think here. What we do is equals minus number. I'll just move ahead for now, come back to this later with a fresh mind. We have a triangle, the equations of the altitudes have been given, and been given 1 point. So I suppose what they mean to say is the point on this line, x plus y equal to 0, if you keep varying that point, then how is the centroid going to change? So let's figure out. And then this triangle. This is have to. So I'm not really sure what we're supposed to do here to figure out what the centroid is. This might get a bit lengthy, so I'll go to the next question. No. Consider the system of equations. Okay, so you want these equations to be consistent. So another way of saying this is that, okay, yeah, let's just write down the equations. I think it'll be easier to think about that way. And then bx plus y equals to 2a and ax plus by equal to 3ab. So now if a equals b equals 0, then it's obviously going to be consistent. So for that, okay, so these equations are homogeneous only if a equals b equals 0. And in that case, obviously, you can see that they are always consistent. So you can y equals 0, x equals 0, that's a solution. So ignoring this case when they are homogeneous, if you look at the case when they are non-homogeneous, then we want this determinant a. Let me just think about this for a while. Now, if even one of a or b is 0, then this entire thing will become 0. And then one of these two will become 0. So that means you always get an equation of the form. You always get two equations of the form. So let's say a becomes 0, you get y equals b. But then you also have two homogeneous equations which say that x equals y equals 0. So let me just write that down. So if one of a or b equals 0, then even by looking at it, if say a is 0, you get y equals b and y equals 0. So this is only consistent when b equals 0. So that means if one of them is 0, both of them have to be 0. Now let's look at the case when so they are equal to 1 or 2. One way of thinking about these equations is to write them down as vectors. So often when you are using determinants and stuff to figure out how linear equations work, this is basically what you're doing. So I've just rewritten the equations as a vector equation. So what I'm saying is that a linear combination of these two vectors, it gives me this vector. So now that is possible only in two cases. If these two vectors are parallel to each other, then this vector must also be parallel to these two, because otherwise you're not going to be able to get this vector from these. And if these two vectors are not parallel to each other, then you can always get this vector from these two. So we only need to check for the cases when these two vectors would become parallel. And since you have 1 and 1, the first two components, that if this is parallel to this, you would have a equals b. So that the only case, and you have a here, and if a equals b, the only case and they do become parallel is when b, both of them equal 1. So if when that happens, you have x times 1 1 1 plus y times 1 1 1 equals 1 2 3, which is not, obviously it's not possible. So I think finally what you end up with is 0 0 1 2 and 2 1. So you have three possibilities for a and b. Okay, so again, so 0 0 0 is obviously a solution, and they want to have a solution apart from these three. So one way of thinking about this, again, I'll just point this out here. It's generally not taught in JEE classes, but then you can think about the equations this way. Lambda minus 1 0 0. So anyway, let's just write down the matrix for this so that it'll be easy to explain. Lambda minus 1, 2, 3, 0, 0. Lambda minus 1 minus 2 and 1 and lambda minus 4. If we evaluate this determinant, we're going to get lambda minus 1 times, and we want this determinant to be 0, because if this determinant was not 0, then you could have just multiplied both sides of this equation equals 0 0 0. You could have just multiplied both sides by the inverse, and then you get this as the only solution. So if 0 0 0 is not the only solution, then the determinant of this has to be 0. Doing that, you get this. And now they've just asked the sum of all possible values of lambda. So you have to look at the coefficient of lambda squared in here. So this will be lambda square minus plus 6. So the coefficient of lambda square, it would be 1 plus 5. So the answer will be 6. Okay, this is a similar question. So again, you just have to equate this determinant to 0. It's 11. Okay, so in order for this to be 0, I'm not really sure what the options are here, so it would have been easier if we had options. And by it's not. Let's just check if n pi does work. So if theta equals n pi, this becomes 0 and this becomes 1. So this is the determinant of this 0. So one thing I can do there is subtract 6 times of this row from this row. So that's not going to change the determinant. I'll get this is just some number stuff that you'll be able to figure out if you practice computing a lot of determinants. Get 14 and then minus, wait a second. I'll just let this go for now. Okay, so it's just a matter of computing the determinant really and then checking out with the options which ones make it 0. So I'll leave this one. Okay, so now you just if x naught, y naught, z naught is a solution, you have to figure out the value of this. So from the last two equations, you know that this is true, and plugging that into the first equation, you get 28 y naught minus 3 y naught minus y naught equals 12. So y naught equals half and z naught equals minus half, x naught equals 1. And so if you just add up their squares, you'll be getting 3 by 2. That's the answer. Yes, I think we've reached the physics part. So maybe it's about time we went back to the other questions. Yeah, this one I had just left. Okay, so let's just think about this question for a while and see if we can find a pattern somewhere. It's given that f of x equals x square g of x, and also that f of x plus y. And what you have to figure out is f prime of x. So let's do what we did earlier. It's just differentiate this thing and see what we get. 2x g of x plus x square g prime of x. And then somehow you need to get rid of x everywhere, and you also need to get rid of g. So the answer can be only in terms of g prime of x and g of 0. That's been given to us for the options. So let's see if we can do something. So we haven't used this property yet. Let's try using it. One thing that I notice is that if I differentiate x plus 1 instead, f prime of what is it? So I was thinking about this 2x g of x term, and I thought I might get it if I differentiate f of x plus 1, but then I'm not really sure for that. We know that f of 1 is the same as g of 1. Maybe we can use this relation to get a similar such relation for g itself. So that we can figure out the properties of g and then proceed from there. So what this says is x plus y, g of x plus y equals x squared g of x plus y squared g of y. So let me just erase the top part. So if we expand this out a little bit, the thing again is that you don't gain much by putting y equals 0 here, because or x equals 0, because this term is going to go away. So is there something slick even though? So if I just put y equals x, I get 2x whole square times g of 2x. Like I could have done that here as well. What I get is f of 2x equals 2 times f of x. So let's try doing something with this. So that means x whole square g of x equals 2 times g of x. So we are actually able to get rid of the x. That's a good thing. We get 2 times g of 2x equal to g of x. So we get the exact reverse. And now if you put in 0, x equals 0, you get g of 0 equals 0. So that's something useful that we have found out. Let's just write that down. X square. So still we need to find some way. We need to find some sort of relation between g of x and g prime of x. What would happen if we differentiate this, keeping y as constant? I mean, when you have functional equations, you have to try all these sorts of things. Differentiating equations. I don't really know of one good way of dealing with functional equations. Sometimes I think it just helps to like assume that the function is something, a function that satisfies the property, but I don't really know of such a function. Okay, so I have this and then I'm going to differentiate. I get 2 times x plus y. I'm differentiating keeping y as a constant plus equals this thing. Obviously, if you put y 0, you get the same thing. So you have to try out something else. Yeah, I'm not sure if this is going to get us anywhere. Okay, so the one thing we can possibly do is that if since we figure out that g of 0 is 0, if this option is correct, then this option also has to be correct. So we can eliminate these two options. So I guess, yeah, when you're not able to solve a question, I guess these are like good tricks to keep in mind. Just look at the options. So if you eliminate those two options, and in fact you're just left with g of 0 and 0. I have a feeling there might be something wrong with the question because these two options are also the same. I mean, the only way this could be true, let's just go through our reasoning again, make sure we are right. Since f of x plus y equals f of x plus f of y, we have f of 2x equals 2 times f of x. Okay, yeah, I think um, when we cancelled out 0, cancelled out x on both sides, we were assuming that x is not equal to 0. So, when we had this expression as 2x square g of 2x equals x square g of x. So we were able to cancel out x, assuming that it's not 0. So I guess we have still some work to do, figure out what g of 0 is. So I guess maybe we should go on to some other question. I'm really stuck here. Let's try the 10th question. Not sure about this one. About the 12th. Okay, I guess 12th was like there are no options. Okay, so this one I guess we'll have to figure out a easy way of doing it. Then we were also left with these questions. It was 25, 26, and 20. 26. Is it something that I okay, yeah, these are questions that I want to come back to, so I'll just mark them for review. Okay, so I think we're left with these 6 questions that we want to try and solve. And let me see if I can So let's try doing this one. I still don't have a anything clear on my mind, but I guess you can go ahead and see what comes out of this. Beta sin x equals gamma. And now we want to look at the range of values that 2 gamma by 3 alpha plus 2 beta can take up. I guess one way of doing this might be to just, we've also been given the roots of this equation. Their sum is 3. So what does that tell us? Let's try plotting this function on the right and see what it looks like. So at x equals 0, it would be this, and at minus pi by 2, you take up minus 2 beta. So maybe something of this sort. It looks between 0 and pi by 2. 0 takes on pi by 2, it takes on 2 beta. Okay. So that means it's a monotonic function. So we just plot it again. So between minus pi by 2 and pi by 2, it goes off from, we put minus pi by 2, this becomes minus 1. So you go off from minus 2 beta. Let's say assuming beta is positive, you can go this way. And then at 0, it's equal to root 3 alpha. And then at pi by 2, it goes back to this. So it seems to me like that it's a monotonic function, but I'm not really sure. So if it is a monotonic function, then it only has one root. Then this equals gamma. So that means both a and b are equal to pi by 6. So you can do root 3 alpha times cos pi by 6. That will be root 3 by 2 plus 2 beta times sine by pi by 6. That will be 1 by 2. This is equal to gamma. So you have gamma equals 3 alpha plus beta. So you have 2 times of 3 alpha plus beta divided by 3 alpha plus 2 beta. We need to figure out the range of values that this can take. So if you just call alpha by beta equal to x, you can do this because beta is non-zero, which is so in the question. You have to figure out the range of this thing. 3x plus 1 divided by 3x plus 2. So I can write it further as 2 times of 1 minus 1 by 3x plus 2, and this can take on values from minus infinity to infinity. the range of this is going to be from what happens. Okay, so obviously when x equals minus 2 by 3, this will blow up to infinity. Means this, no, there's to be something wrong with the question. It's just calculate the value of gamma value. So just got that gamma equals root 3 times root 3 by 2. Okay, so you get gamma equals 3 alpha by 2 plus beta. So in fact, we get gamma equal to 3 alpha plus 2 beta, which means 2 gamma by 3 alpha plus 2 beta is just equal to 2. Now what would be this interval? I mean, I'm not sure why they've called this an open interval. But yeah, so I'm not really going to answer this question, but 2 gamma by 3 alpha plus 2 beta will be equal to 2. If pi by 6 is a solution, I mean, is the only solution, because yeah, I guess the function must be. But actually, now that I think about it, the function doesn't have to be 1 to 1. So if it isn't, then it will turn out end up having more than 2 solutions. So let's just do it again. Gamma equals this with the extra restriction that the solution of this, the sum, the solution of this should equal pi by 3. What does that mean? That means we also have this equation to be true. Pi by 3 x. So we solve this, get of cos x 3 by 2 sin x plus 2 beta times root 3 by 2 cos x minus half sin x equals 1. So what we end up getting sin 2 cos x plus 3 beta plus 3 beta cos x 3 alpha by 2 minus beta sin x. This also equals gamma. I don't really seem to get something new from this. Okay, so one thing that we can do is replace cos x here in terms of gamma 2 beta sin x and alpha, and then find out an explicit expression for sin x. So basically just solve for sin x and then set the range of that to be equal to -1 to 1. So I think from that we will end up with something for sure. Let me just get rid of this part. So what we want to do is eliminate 6, and then we will try squaring this one. Okay, yeah, so in principle, I guess this is solved because you just have to find out the value of sin x. I'm not really sure about how long it's going to take. So maybe should go try some other question. Yeah, let's try this one again. X square plus square minus a by square equal to 0. A is greater than 0. And we have x 3y plus 8 equal to 0. And now we want to find the value of a plus 8. Given the fact that these three form an isosceles triangle. Now it's right angle to the origin. We know that already from the equation of the pair of straight lines. So what we want to do is figure out the points of intersection of this with this, and then make their distances equal from the origin. Let's try that out again. Something else, it might help if we just make a diagram of this sort. So you have the line going like this, and a pair of straight lines passing through the origin. So just do this. So you have this basically. These are the two lines, and then you have this third line cutting them through like this, so that these two lengths are equal. And now you want, assuming that this is the origin, so these 2 points satisfy the lines. So one way you can probably do this is by just subbing in the value of y here and then solving. Then it looks like that will take a long amount of time. So I think a better way of doing it might be to do what we did earlier. We'll consider these 2 points. We'll consider the points of intersection to be of this form, where theta can take on two values, so alpha and alpha plus pi by 2, because the angle it subtends at the origin is pi by 2. So let's try doing it that way and see if we get somewhere. We'll also figure out r by saying that it's a chord. This is a chord that subtends a right angle at the origin. So if we have this circle equation, then 2x plus 3y plus 8 is a chord that subtends the right angle at the origin. Here it's just the points to be r cos theta or sin theta, and cos of theta plus 22 is going to be minus r sin theta. So both these points, they should satisfy this line. See that cos theta plus minus 8, and you also get minus 2r sin theta plus If you just square up these equations and add them, you're going to get 4r square plus 9r square plus get 2 times 3r 2r, so that's get a sine 2 theta here as well as theta there. So you get 6r squared 12r squared sine 2 theta equal to 64 times 2, that's 128. So you get 13r square is 12r square. But then we can also put in these values in the equation of the other line. So doing that, we get a cos 2 theta, which sin 2 theta equal to 4. And also we get minus a sin 2 theta minus a cos 2 theta plus h sin 2 theta equal to 0, which means cos 2 theta has to be 0, if I'm not wrong. And this will be minus. Okay, I see that the same thing here. And then summing that, get tan theta equal to minus a by h in both cases. And you figure out sin theta and then figure out r from that. Then once you have figured out r and theta, how do you figure out the points of a image? So I'm not very sure about this. I even think it's about to end right now. So I guess it was not like very instructive because it was just me mostly solving questions. But yeah, I hope you got to learn something from this. So I'm going to close this now.